Now that we've talked about polynomials, we will talk about in 12.2 how to add and subtract the polynomials. The main thing to remember when you are adding and subtracting is you have to look for like terms. Remember that talks about the exponent as well. You can only combine things when they are alike. You can do them two different ways. You can do it by adding them vertically, and vertically would be up and down. And this is the traditional way that you learned how to add things, especially if you are renaming. So to add this, the first one vertically, I'm just going to move this the second set here so that it is lined up with the like terms in the first expression. So my 3x to the third, my 2x squared, and then I don't have an x term, but I have a constant term, 7. Now, my like terms are in columns, you can see, and so I can go ahead and combine those like terms. So a negative x and a positive 3 would give me a negative 5, and those are my x cubed terms. Positive 4 and a negative 2, that would give me a positive 2, and those are my x squared terms. I only have the x, so that's added to nothing. Sorry, I could hardly put my plus in there. And my positive 1 and my positive 7 is a positive 8. So my finished product there, without the column marks, would be negative 5x squared plus, I'm sorry, that was cubed, negative 5x cubed plus 2x squared plus x plus 8. Now there's no solving in that one. This is just an expression. Okay, we'll do the same thing on this next one here. I'm going to take my like terms again. My first term in the first expression here is x to the 4th. And in my second expression, I do not have any x to the 4ths. Now, I do have an x to the 3rd, so I will line that up there. I have an x squared. I have an x. And I have a constant term. Now, the first expression might not have a term that the second expression has. We've dealt with the second expression not having a term that the first one does. Again, you would have to do some rewriting, but you would be rewriting both of the expressions anyways because you wouldn't be writing in your books. All right, so again, we'll start over on the left-hand side here because we're just adding the like term. So 2x to the 4th is my only x to the 4th term. Then I have positive 6x, and then remember there's an implied coefficient there. So 6 plus 1, now I have 7, let me exaggerate my 7 there, 7x cubed. Negative 5 and negative 3 would give me negative 8. Those are my x squared terms. Positive x again, implied 1 there. We have 3 x's now because we had an x and we added to 2 more x's. And then negative 7 combined with a positive 1 would give me a negative 6. Okay, so vertically is, if we're going to do it up and down, is vertically. You can also do that horizontally. Okay, horizontally is a little bit trickier. You just have to make sure that you keep your terms together, and I would suggest possibly crossing them out as you use them. So we're going to try to do that one with a story problem. You're saving for a trip to Costa Rica. You deposit $500 into a bank account that earns interest compounded annually. 1 year later, annually means each year. 1 year later, you deposit an additional, so that's adding $600 more into the account. Let R be the annual interest rate. What is the balance A of the account 2 years after the initial deposit? So for the savings account described above, the balance from the first deposit is given by the polynomial. So we'll go ahead and write this down, that we have A equals, okay, and that's going to be the balance of account A. We're going to have the $500 we put in, and we're going to add the, let me find it here. We're going to add that we have the 1,000. I guess this page doesn't show all of the information from the first page. So we're going to use the rate here, and we're going to also add 500 with that rate squared. And this is example 2 in your book. Now we need to do the second year then, which is going to be, if I can fit it in here, 600 plus 600R. Just squeeze it in there. Okay? Now we have to do some combining terms to understand that one. So we'll start out with the first term here, and it's a constant. So the 500, in our second expression, do we have a constant term? We do. It's the 600. Notice I put the squiggle lines under it. You can circle and square. It doesn't matter, but you want to make sure that you're seeing both of them. So if I combine the 500 and the 600, I end up with 1,000. Okay, now I want to see, do I have any R terms? I have 1,000R here. Do I have any in the second expression? I do. So I'm going to combine the 1,000R with the 600R. And so that would be 1,600R. Do I have any other expressions that are left? I only have the expression, or any other terms. I only have the term in my first expression. Second expression did not have an R squared term. So when we combine that polynomial, we did it horizontally. Again, I would either code it with some shapes or underlining, but maybe crossing out 2. Let's see. We have, after 1 year, the balance from the second deposit is given by, this is slightly different than what that you have in your book. So I'm going to go ahead, and I don't want you to get confused if you're following along with the example in the book. So we want to know what's going to happen if the rate is 0.02. So they're going to give you a value for your variable there. So if the rate is 0.02 or 2%, we're going to find out then that we can substitute that in to our equation after 2 years. The 2-year one is what we're going to substitute in is our equation right here. So we're going to substitute 1,000 plus 1,600, but we can go ahead and put in our rate now, plus 500. Again, you can put in our rate, but remember we have it squared there. Okay, so we're going to multiply that out, and I think I had a mistake somewhere here. Oh, I do. I just looked and I found it. And I'm trying to, I think 500 plus 600 should have been 1,100. And I was looking at the discrepancy between my screen. I didn't notice that. 1,100 there. Okay. Now we can go ahead and multiply out the ones we substituted in. So it's going to be 1,100 still. And then we're going to multiply out, the next part would end up being 32. You can do that in a calculator. And our next term would be 0.2. So if you add that all together, I'm going to put it vertically here just because I'm running out of room. Your new balance would be $1,132.20. So we didn't do a great job with the story problem part of that just because there was some discrepancy, but as far as learning how to add the polynomials horizontally, we did do that in this first set here, and then substituting in the variable is what we worked on for the second step. All right, let's go ahead and move on. That was the screen I was looking for, and we're going to look at subtraction. Now, subtraction, I would definitely recommend doing that vertically because subtraction has to do with more of renaming. So I'm going to actually rewrite the whole thing here so we have enough room since we have the whole slide. And we're going to subtract 2x squared minus x plus 8. Now, because we're dealing with integers and we're dealing with subtraction, we're going to find the difference between these, okay? So again, add the opposite sometimes confuses us a little bit, all right? So we're going to look at -7, and we're going to subtract a +8. -7, and we're going to subtract a +8. So if we do that, we want to add the opposite, so this changes into -8. So we end up with -15 here. Add the opposite here, I change that one. Add the opposite here, I'm changing that one. So now we have 4x plus x. We should end up with 5x there. And we have 6x squared subtract or combined with a -2x squared. So we end up with 4x squared. Okay, so add the opposite. Now, if you try to do this horizontally, again, just make sure you're watching your terms here. The first thing I would do, I am still going to rewrite this just so I have enough room to manipulate it. We're going to, again, add opposites. Okay, add opposites. So I'm going to change every label here, or every signage, I'm going to change the opposite. So in the second one, I'm going to, the rules are for adding, so I'm going to put my add. I'm going to change +4x squared to a -4x squared. -5x is going to change to its opposite, +5x. And +11 is going to change to its opposite, -11. Now again, I can do my combining. I have an x squared and I have a -4x squared. We're going to combine those. And if you combine those, you should end up with a +3x squared. I have a +4x. Notice I'm just showing you a little bit different coding now. And I have a +5x. 9x. Got rid of my x terms. And I have a -9 and I have a -11. Combine those and I get a -20. And I have used all the terms in both of the sentences. So that is how I would represent that expression. And that finishes 12.2.